Okay, so in the previous video, we looked at some reminders about simplifying our operations with rationals. And so in this video, we're going to talk about solving our rationals. So the first reminder that we need to talk about when solving rationals is that when we're dealing with rationals, it's really important that we check our restrictions. So we find this restrictions very beginning of the problem, and then we go ahead and we work from there. Now, when I think about solving a rational, I kind of break it up into three goals. So we have goal number one, and goal number one is to use addition and subtraction to simplify each side of the equation to one fraction. Now, sometimes you might bring one of the fractions to the other side via addition or subtraction because they have a better denominator over there. This process could look different problem by problem, but this is our big goal, is to get each side of the equation down to simply one fraction. Once we've completed that goal, we can move on to goal number two, which is get rid of the denominator. At some point in a problem, we have to get rid of our denominator in order to go ahead and solve. There's really two big ways that we can do this. So one of the ways that we do it is we cross multiply. This is best when denominators have nothing in common. So if you get to a point in a problem where you have x over x plus 2 equals 5 over x minus 1, x plus 2 and x minus 1 don't have any factors in common, and this is where you'd want to cross multiply to get x times x minus 1 equals 5 times x plus 2. That is how we can cross multiply, and like I said, it's really useful in examples like this when our denominators don't have anything in common. So the hint there is, what about when they do have things in common? So if they do have things in common, we can use part B, which says if the denominators are the same, set numerators equal to each other. And so what that might look like, in one of our earlier examples, we had x over 5 equals 2 over 5, and we were able to say that if 5 is the same, then in the numerator, these must also be the same, and we can just quickly say x equals 2. Now, sometimes it looks slightly more complex than that. Say that I had x over 5 equals 6 over 20. Well, 5 and 20 are actually pretty similar. In order to make 5 into 20, it needs a 4. So I can multiply this side by 4 over 4. That gives me 4x over 20 equals 6 over 20. And now I see that my numerators and my denominators are the same. So I could say 4x equals 6, x equals 3/2. So the reason why I'm illustrating this here is to show you that if they're already similar, you can go ahead and use a well-chosen one to get the denominators to be the same, to set the numerators equal to each other. So that is a common method that we'll use as well. So once we have completed goal 2, which is to get rid of our denominators, we can move on to goal 3, which is the major goal. Calling it the major goal because it's actually the goal of the entire problem, which is solve for x. And a reminder here that you're solving for x if quadratic, set entire problem. equal to 0, factor, and solve. So as we can see, our reminders here for solving are definitely more. So solving is a slightly more complex problem than just simplifying. In fact, goal 1 is just doing what we did in the earlier slide of simplifying. Once we complete goal 1, we still have goals 2 and 3 to complete. So getting rid of that denominator, and then the major goal, the goal of the entire problem, which is actually solving for x. So let's go ahead and see what this looks like in a problem. So as I said, the very first thing we want to do is we want to check our restriction. So because I have x plus 6 in the denominator, I automatically know that x cannot equal negative 6. Because I have x minus 3 in the denominator, I automatically know that x cannot equal positive 3. I have to check this denominator as well, so I'm going to factor it. I want to know what two numbers multiply to give me negative 18, but add to give me positive 3. So negative 18 is going to be a negative number and a positive number, probably 6 and 3. They add to give me 3, so the positive number has to be bigger. Well, when I do that, I notice immediately they're the same factors I already saw over here. So I actually already found those restrictions. Now I can go ahead and move into goal 2, into goal 1, which is get this side down to 1 fraction. In order to do so, I need to add, or subtract, but they don't have a common denominator. So that's my first thing I really need to do is get them to have a common denominator by multiplying by that well-chosen 1. So I'm going to do x minus 3 over x minus 3 times 3x minus 1x plus 6 minus 2x minus 3 over x minus 3 times x plus 6 over x plus 6. So I took this denominator, made into a well-chosen 1 for the second fraction, and I took this denominator and made into a well-chosen 1 for the other fraction. Now this is that really big part we talked about with adding, subtracting, that we actually have to multiply here. We have to get through the multiplication in order to get to adding and subtracting. So if you're following along there, I was distributing each of the terms in the front binomial to each of the terms in the back binomial. Now this is a really important step. This is what I hadn't read on my last slide, my last video, which is when you have subtraction, you have to distribute this negative all the way through. So you distribute the negative to everything in the numerator behind it. So I can go ahead and make it a positive. That means this becomes a negative. This becomes a negative. This becomes a positive. This becomes a positive. And make sure that you're doing it in a way that you can follow your own work. Now that I've done that, I can go ahead and combine like terms. So I have 3x squared minus 2x squared, which gives me positive x squared. Negative x minus 9x gives me negative 10x. Negative 12x plus 3x gives me negative 9x. Those together give me negative 19x, leaving me with 3 and positive 18, which is 21. At this point, I have finally gotten my first side down to 1 fraction. So I'm going to remind myself that it is set equal to something and go ahead and solve or get into that solving method. So here, I would say I was working on goal number 1, which is getting this down to 1 fraction. Now that I've done that, I'm ready to move on to goal number 2, getting rid of that denominator. Well, we said if the denominators have anything in common, try to just get the denominators to be the same so you can set the numerators equal to each other. Well, in order to know if they're common or not, I need to look at this denominator in its factored form again. Well, as we saw from above, this is its factored form. And right now, these are the same. So I can say my denominators are actually the same. So I can immediately set my numerators equal to each other. So once again, since my denominators are the same, I can set my numerators equal to each other. Which brings us into goal number 3, which is actually solving. We said if it's quadratic, bring everything to one side, factor and solve. So I'm going to add the 3x squared over. Now, in order to factor this, I need to multiply my a times my c, identify my b term. I want to know what two numbers multiply to give me 84, but add to give me negative 19. Sometimes this does take some trial and error. Those numbers are negative 7 and negative 12. 12 times 7 is 84. Negative 12 minus 7 is negative 19. When you find those two numbers, you bust apart your b terms. We're going to substitute them in for b. That gives me 4x squared instead of negative 19x, am I right? Minus 12x minus 7x plus 21 equals 0. I get this question a lot. It doesn't matter which order I put these in. No, it does not. I like to put them in a way. I know I'm pulling out greatest common factors. So I know 4 and 12 and then 7 and 21 had a common factor. So I put them in that order. You don't have to. If I put them the other way, my factoring steps, my next two steps would look different, but my final factored form would be the same. So now that I've done this, now that I've busted apart this b term, I no longer have negative 19, I have negative 12 and 7. Once again, we chose negative 12 and 7 because they add up to give me negative 19, and they multiply to give me 84, which is what 4 times 21 is. Now I'm ready to factor by grouping. I'm going to group the first two terms and the second two terms and look for those greatest common factors. In the first, they're both divisible by 4, and they both have an x. That leaves me with x minus 3. In the second one, I can bring out a 7, and then because this term is negative, I need to make that a negative 7. That leaves me with x minus 3. That means that these two come together to make one factor, 4x minus 7, and the other two come together to create my other factor, and I fully factored it. In order to solve this, you simply take both of your factors and set them equal to 0. Solve those, we get x equals 7/4 and x equals 3. Now, we are super duper close, but our last step is to check those restrictions. I found them at the beginning, but now I have to check them. 7/4 isn't here, I'm good. 3, that's a restriction. So I'm going to mark that answer off, and we find out that x equals 7/4 is our final answer. So just to step you through again, I found my restrictions. Goal 1 was to do the actual subtraction to get this down to one fraction. So then I had to multiply by my well-chosen ones. I had to distribute my negative. I had to combine like terms. So that was to get me down to one fraction. Once I did that, I moved on to goal 2, which was to get rid of the denominators. This problem was a lucky problem where my denominators from the get-go were equal to each other. So I just set my numerators equal to each other. Then I moved into goal 3, which was solving. In order to solve, I moved my 3x squared over. It was set equal to 0, so I was ready to factor it out. Once I factored it, I set each of those equal to 0 to solve, and then I just checked our restrictions. My restriction said x was not allowed to equal 3, so I immediately canceled that one off, leaving with x equals 7/4.